Now let's talk about a topic that we can't escape in any tech conversation today. Generative AI has taken the tech industry by storm, and we're seeing an explosion in interest from Redis customers for making it a part of their LLM supporting apps. For all of us that are excited to learn more about AI, our upcoming panel will discuss different components of the generative AI application stack. Our panelists are domain experts from Nvidia, Relevance AI, Insight Partners, and of course from Redis. They'll discuss the intersection between LLM popularized by the famous ChatGPT service and lesser known components like integrators and vector databases. Without further ado, I'll hand it off to Sam Partee, Principal AI Applied Engineer at Redis, to kick off our panel. Sam, take it away.
Hey everybody, thanks for coming to this Redis Days panel. We have some awesome people with us today. First, we have Jacky Koh, who's a founder of Relevance AI. We have George Mathew, who is a managing director at Insight Partners. And we have Jonathan Cohen, who is a vice president of applied research at Nvidia. So, I want to start simple. I want to talk about what everybody right now is talking about, which is large language models. And I know that Jacky, you've been doing a ton of work in this area. So why don't you start everybody off by giving kind of a quick overview or sample of what exactly a large language model is and what it's used for?
Sure thing. Thanks, Sam, for the question. So, a large language model is essentially a type of AI model designed to understand and generate text. It is normally trained on massive amounts of text data and uses deep learning techniques to analyze and generate coherent and contextually relevant responses. So, popular large language models such as OpenAI's GPT-4, Anthropic's Claude consist of deep learning neural networks with many, many layers, sometimes often to the billions of parameters. They can process and understand nuances of human language, including grammar, syntax, semantics, and even some level of contextual understanding as well. So one of the reasons why large language models are so popular right now is because it generates such human-like responses and text, and it can enable a very wide range of use cases, such as machine learning translation, semantic analysis, chatbots, and many, many more really incredible use cases as well. So yeah.
Absolutely. And I'm sure we're going to talk about a lot more of those. I'm curious, George, what do you think about the dichotomy in the ecosystem that we see between the closed source models and the APIs and LLMs behind someone like OpenAI or Cohere, and then some of the open source ones like Hugging Face, rather, that have a repository of many models that anyone can access at a given time. How do you see that dichotomy playing out?
Yeah, I'm glad you asked the question. When you look at where the open source models in particular have really emerged in the last, I would say, even several quarters, and certainly, a repository like Hugging Face really being essential for distributing and scaling some of the open source activities that's going on, particularly around transformers. What we generally see is not necessarily this idea that like the two are in competition with each other. We see a fair amount of open source innovation that continues to evolve as new models that are particularly small form factor in nature continue to come into the market. And when you compare that against the larger research shops that are Cohere, Anthropic, AI 21, OpenAI, they're working on large language models that couldn't have as much as theoretically today a trillion parameters, and the training runs involved with that are quite prodigious. When you look at the comparison of the two, there is a fundamental amount of research that continues to evolve in the large language model providers building these trillion plus parameter large language models at scale. But simultaneously, we're noticing that to get the same effectiveness in terms of language and be able to have, to Jacky's point, domain specific computations that are now sort of added to the large language models that can be smaller in terms of their training runs and frankly more efficient in terms of inference, we're seeing a lot more innovation happening in the open source side of the world. Over time, I generally believe that there's going to be a number of mixed ensemble-based use cases of both the large language models being deployed by the research shops that are being leveraged by the enterprises that are, leveraging the sort of full capability and fine-tuning those models alongside of building your, call it, domain-specific models off of an open source offering, and those open source offerings continue to evolve. So the two should ideally coexist with each other as opposed to being tremendously dichotomous and competing with each other.
Yeah, wow, that was a great answer. And honestly, it's something that I've seen as well is that people are taking those open source models, fine tuning them, using them for specific purposes. Whereas the GPT-4 like approach can be used kind of more instruction led, broader reach, general use cases. That makes a lot of sense. You were talking about trillion parameter models, and obviously NVIDIA is involved in the backbone of this ecosystem is the NVIDIA GPU in a lot of ways. And so, Jonathan, I'd love to hear from you on kind of what NVIDIA thinks their role in this ecosystem is when it comes to these open source models, when it comes to, obviously working with people like the OpenAIs, the Anthropics, Amazon, the cloud providers, et cetera. Obviously that GPU is so important. How does NVIDIA see themselves fitting into this ecosystem where they are so crucially involved?
Well, our role in the world is to enable people to do amazing things. So, it's clear that if you want to train the biggest models or serve the biggest models, you need accelerated computing. There's just no way you could keep up with the computational demands on traditional processor. Um, GPUs have become essential for doing this kind of work. And even with a GPU, you can still have, training runs that take months on gigantic supercomputers. So it's like barely feasible today. Imagine if you didn't have accelerated computing, where you'd be. Um, we like to Jensen, our CEO, likes to say we're the AI company that works with every other AI company. We partner with every cloud provider. We partner with every large language model startup. We have this Inception program where we partner with all the startups in the world. We're super happy to see a thriving ecosystem. Um, we release lots of the fundamental technology from the hardware platform to software to deployment to things like Triton that make it easy to serve your models. The Nemo project, which is what I lead, which has many components, many of which are open source. Nemo guardrails, which is a layer for trying to create guardrails around your LLMs, which is another project we've open sourced. So, we see our role really as enabling this entire ecosystem. We are thrilled to see the proliferation of open source models. We're thrilled to see some of the leaders really pushing the state of the art at the limits of what's possible, and everything in between. And we're very excited to see where this is all taking us. And I think when we started working, really getting serious about deep learning about 10 years ago, we kind of had this feeling someday there's going to be a killer app, and I think we're finding it now with generative AI.
Wow. Yeah, that was really great. One thing I've always respected about NVIDIA too is the composition of the infrastructure from everything from something like a Triton, right, all the way down to something like a Bluefield, a networking chip like a NIC or InfiniBand, constructing the entire DGX system. NVIDIA is owning almost every single piece in that system, and some of the acquisitions like InfiniBand were really well done because of that. They were able to put those end-to-end systems together. And
You mean Mellanox? Mellanox.
Mellanox, excuse me,
Yeah.
yeah, absolutely, yeah.
Get the company name right.
It's the product, right? No, absolutely. So yeah, on top of that, I did want to kind of shift gears a little bit and talk about vector databases. This is something that is particularly interesting to Redis because over the past year and a half, we've been starting to offer this capability that we call query and search, and really what it allows someone to do is just like they would store data in Redis traditionally in a hash or JSON document, they can now store vector embeddings created by these large language models. They can be indexed and retrieved in conversational loops with things like LangChain. And it's a really compelling offering that we've seen a lot of people starting to use Redis for. And obviously my team's involved in this, and we've seen so many different use cases crop up. And obviously Redis being a very composable store, there's a lot of use cases for it in general, from messaging, or PubSub all the way to vector database. But really, the advent of the combination of vector databases and large language models and using them together has created a really interesting ecosystem and set of use cases. And so I'd like to dive into that. So specifically, I'm going to throw it back to Jacky. How do, because I know that relevance is very involved in this space and in chaining in general. How do large language models work with vector databases? I think it'd be good for everybody to get a grasp on that.
Sure thing. Thanks for the question, Sam. But I like to kind of describe when it comes to vector databases and how it affects LLMs. It can be described as giving LLMs the ability to have memory. So, why is memory so important in this specific context? It's because LLMs out of the box can hallucinate. It can not really work on your specific context/data. Vector databases is a very popular technique that enables you to retrieve the most relevant context from a very large corpus of data that you give it. And there, it's able to do this at query time so that it can give the relevant context to the LLMs so that it doesn't hallucinate as much, so that it can work on your specific context. By giving the LLMs essentially this memory, you're able to enable really popular use cases such as Q&A chatbot and also autonomous AI agents. There's other really popular use cases as well when it comes to vector databases and LLMs besides memory, such as like semantic caching that I won't go further down deep into, but databases such as Redis is really popular for that as well. So yeah.
And semantic caching is something that is coming up a lot. And that might just be because Redis has also been traditionally used as a cache, and in addition is now a vector database. But it is something that we see coming up a lot because it allows you to both, increase your queries per second, and at the same time, because you're not actually going to an LLM that has a QPS of like 5. And you also save on the cost computationally and monetarily. So semantic caching is something I can see becoming even more popular in the future. But also, I know
Precisely.
NVIDIA is involved here, and there's the Raft and the Rapids projects. I know it's integrated into FICE, and there's obviously work going on with in between Redis and NVIDIA here. But how does NVIDIA see this kind of vector database ecosystem, and what are they doing going forwards here?
Yeah, I mean, we think it's hugely important. If I could add to something Jacky was talking
Sure.
about, by way of some context. So there's this notion of grounding when you talk about any kind of linguistic system. So if I ask you, "What's the weather outside today?" you don't close your eyes and just say it's sunny. You actually look outside. You ground your answer in some objective truth, and so you have some way of knowing that objective truth. The problem with language models that are just trained on text is they don't have access to the external world or to truth. They just have access to what's stored in their digital neurons. Um, and and so if you want to use a language model in any kind of real system, you somehow have to ground it in something that you can consider true and that you can control. One way is to connect it up to APIs or sensors, but a really obvious thing to do is connect it into the actual knowledge base that if you're a business, that powers your business, the real data that you know is true. And this is why vector databases are so important, because they're a great way to store this data and allow a language model to access it as it needs to on demand. So when I ask a language model a question, rather than just making up an answer that's linguistically plausible, the first thing I do is I find relevant facts, which is a vector search in a vector database. And then I tell the language model, hey, here's some relevant facts. Now, how would you like to answer? Right. And I think there's a lot of evidence at this point. While not flawless, this is a pretty good approach, and there's lots of cases where it works quite well. And so I think this is why it's essential to the future of language models. Computationally, now you've created this workload that's pretty sophisticated and complicated to do efficiently. You're no longer just asking a neural network to inference and serve. You now need to connect it into search and databases and potentially ranking and all kinds of complicated filters and for example, does this language model even have permission to access this set of facts? If I have a large organization, not everyone is able to answer every question. Not everyone is able to see every fact, and so you really need a real database, I think, in the mix. There's lots of cool demos where people do very simple things, but when you start to build something that has to actually serve a real enterprise, you really need to connect it to a real database, and you very quickly get into the world where, okay, this is a real database now.
I
And so
love
we
that.
see this as
I love
Exactly.
it.
And so we see this as super important. The computational part of that now becomes very complicated and heterogeneous and challenging. And so we have projects like Raft, which are taking the core kernels involved in the nearest neighbor search, which is kind of like the heart of a vector database, and showing how you can accelerate that on our GPUs. But really, just the entire process is now a very complicated, heterogeneous thing. And if you want to optimize for like the overall user experience, you want the quality to be high, so you need high quality embeddings. Maybe you want a lot of search results, but you also want low latency. And so this is, I think, where we can play a part, is to help boost both the quality and lower the latency simultaneously with our software and hardware.
Absolutely, and I've seen a lot on Raft, and it is some really exciting work. I've also, one thing to point out here is too, what I've also used before is the Triton ensembling technique, as well as like something like Merlin systems, where there are multiple stages. Just like you're saying, it's not just an inference anymore, and that pieces in that ensemble could be like, say, Python models that are doing a retrieval from something like a vector database and providing that as input. And so I know that there's also a lot of ways to do this in the NVIDIA ecosystem today. So that's really interesting. Shifting gears though, I want to hear from George on what you think about this space, because there's so much money being poured into all of these startups. And just like Jonathan was saying, there's also these database providers that are coming, and like Redis, that are coming and providing this as well. And there's a lot that has to be done on the database side for some companies. There's a lot that has to be done on the search side for some companies. And once again, we're brought to a space where there's seemingly like almost a dichotomy of sorts. Your answer to the last one was so perfect. I'll use that word again. What do you think about this space when you're looking at investing in it?
So we took a view that this was effectively a series of hyperstacks built on top of each other. And the first starting point of the hyperstack was a lot of the modern data stack that emerged in the last decade or so. And that was both for analytical and transactional workloads. And so when you looked at where the modern data stack went, it was really about sort of processing, scaling the processing of data, whether that be for transactional order taking purposes or for analytical data processing. And what's really fascinating to see is how much we've now started to see the sort of key players in the modern data stack add vector support, including, of course, what Redis has done in terms of vector support. Now, that's mainly because we're seeing vectors as a data type becoming so essential for both the analytical and the transactional workloads that are surrounding all the things that are above the layer in this modern data stack. And what are the layers above? Well, first and foremost, it's MLOps. And this is an area that we spent a lot of time at Insight, really particularly looking at where the investment opportunities were. Two companies I've, of course, highlighted, of course, Relevance was doing a lot of work early on to just be able to provide initially vectors as a service, and now almost a low code, no code experience for building these applications largely using the capabilities that we all just described a moment ago. And another would be a company like Weights Biases, which is really focused on all the experiment tracking and the hyperparameter tuning and the version controls that are necessary to build large language models and just generally deep learning models. And so the reason that MLOps and LMOps layer continue to evolve and continues to accelerate is because you're seeing this first generation of generative AI applications. And that's what I would think of as this third layer in this hyperstack. And in there, you're now bringing together a domain specific model, perhaps private data sets, adding workflows, adding UX, and building full stack experiences for very specific needs and purposes. Good example of this is the investment that we made in Jasper. And so Jasper was really targeting the content marketer themselves and being able to produce a solution that would really 10x the capabilities of what the output of a content marketer would be able to do with or without Jasper. And the underpinning of that was, of course, a finely tuned model from OpenAI with the capabilities that were eventually kind of built out as a domain specific model that Jasper itself owned, and a great UX and a great workflow that supports how a content marketer works on a day in, day out basis. And so we kind of think that there is an ongoing relationship between how the data is managed effectively over time with the support of vectors and additional capabilities in both the transactional and analytical workloads. The tools and platforms that are necessary to build and deploy models at scale. And we talked a little bit about two examples being weights and biases and relevance. And then three, these full stack applications that are emerging across horizontals as well as vertical use cases. And we are investing pretty actively in all three of these layers of the hyperstack, with looking for those opportunities where there is either a differentiation that might occur in the data layer, a differentiation that might occur in the tools and platforms that are necessary, or the applications that are being delivered to the end users themselves. And so, yeah, it's a tremendous moment right now. If anything, this is the only part of the market where, despite whatever the rest of the space from an overall tech standpoint has been largely, challenged as far as valuations, and there's largely been a downturn in the rest of the market, it does feel like we're at a prime moment in all things related to generative AI, whether that be the applications, the tools and platforms, or the data infrastructures.
Wow. I mean, I hope this is recorded. I know it is, but wow, that was an incredible answer. I mean, you saw what happened with Mosaic and Databricks recently. I mean, the valuations per employee right now, the things that are going on. I mean, you're right. It's absolutely this space in tech that is let's say protected in valuation, and really because it's producing such interesting things like Relevance and like Jasper. And so, kind of, I'm going to throw something back at you that then I'm going to take to Jacky. So, on that, you mentioned building on that kind of third layer, and I'll call that third layer something like a relevance or like a lang chain, where there's kind of another application. And you mentioned user experience, right? And so, I know that with your investments, that's something that you thought through. And I, obviously, being a user of Relevance myself, I've noticed how the user experience can make using generative AI easier. How does that factor into how you think about these platforms and how you think about how they'll be successful in the future?
Yeah, and one comment as I'm answering that question is, what happened this past week with Mosaic ML, and you kind of commented on
Sure.
it already with the fact that the Databricks team acquired Mosaic this past week. Well, when you think about the contextualization of why that happened, it's the fact that the folks that are in the data layer are naturally ascending into the tools layer, and a natural way for them to do that was to acquire a up and coming leading provider of training tools, right? And in a lot of ways, Mosaic was one of the leading up and coming training tools that was being consistently used, and it gives a company like Databricks more space, right, to own and occupy as it's going kind of more vertical in the stack. Now, going back to the point of where this continues to evolve, from this moment on, I mean, we just see a lot more opportunity, particularly coming about by really understanding which personas the products and services, particularly in the tools space, is really supporting. And what we really love about Relevance was it's very unique in the fact that it's much more targeted towards a higher functioning business user instead of just the developers only. And so there is plenty of developer capability with Relevance and plenty of the other names that were just recently mentioned, but most of the other names are predominantly just focused on the developer experience and not as much for a business user having a more low code experience. And what we've noticed over time is that in every one of these markets, there's almost a citizen version that emerges, whether it be a citizen data scientist, a citizen developer, and in this case, I believe a citizen LLM builder. And in a lot of ways, what we see with what Relevance is doing is really catering to that expansiveness of folks that are going beyond the developers themselves to be able to build LLM-based applications.
Yeah, I love that citizen layer that you're talking about. That's a great term. Jacky, I'm going to let you expand on that, but I also want you to touch on the chaining piece that you mentioned earlier, and also add that into what he's talking about in that kind of citizen level UX, and how does that play into chaining? How are things like vector databases used in that chain, and agents, and how are how are they connected together in a platform like Relevance?
Yeah, sure. I'll start with explaining the chains and agents bit. But it really comes from the fact that out of the box, LLMs can only solve simple problems. due to the fact that it has context limits, it can hallucinate, it doesn't work on your own data, and it produces inconsistent results. For enterprises and businesses, these problems mean it's insufficient to go to production with just the LLM model itself. So that's where chaining comes in. So AI chaining is essentially the technique to combine LLMs with really powerful techniques such as internet browsing, unstructured data transformation, vector databases, Nemo guardrails, and even Redis semantic cache. And all these different techniques allow you to overcome a lot of the inherent limitations of LLMs so that you can use it to actually solve more complex problems at a more consistent rate. And this allows you to essentially create workflows that is able to really solve one specific task very accurately, reliably, and securely. So that means that to use cases such as like chatbots and also like passing of millions of unstructured data, you can now do this much more reliably. Don't have your prompts being jailbroken. You can also be able to be confident in the results and making sure that it's all consistent. Now, when it comes to the agents, they are essentially like an LLM powered bot that can independently break down complex problems and then iteratively solve them and take actions actually on behalf of the users. In the context of chains, agents are able to actually pick up a chain or multiple chains and actually use them as tools so that when it is being given a problem, it can automatically decide between all these different chains and tool sets which one to actually use to best solve for the problem and the goal that it's been given. This can enable really cool use cases, such as like giving an agent a task of, I want you to understand the average profit of the top Fortune 500 AI companies. So it's able to then automatically scour through the web, find out what are the actual Fortune 500 companies that have AI projects in them, automatically find the financial documents, and then automatically process and pass and summarize all that information so that it gives you that coherent answer at the end. So using both chaining techniques and the ability to build agents, those are both techniques that not just developers want to be able to have, but because of the rise of citizen, we call it citizen prompt engineers, citizen LM developers. Now anyone can go in and use Relevance to actually build these chains and build these agents and build the most sophisticated LM applications so that the business can really utilize it to its full potential. So yeah.
Love that. Building on that, I think I saw just recently a use case where there's a financial document intelligence system where the company's private documents were held in a vector database, Redis in this case, and then it also had access to go and search the internet. So it could go look for public S1s, but then it could also decide if maybe this information was something that's in my private knowledge base, and then it would go search Redis for that. And then, just as Jonathan said earlier, grounds it, and takes that information, whether it's from the internet or whether it's from the private knowledge base like Redis, and it's going to ground then the answer. And so that's just like one example, I think, of what you're saying, Jacky, that really, brings it home, especially for me because I just worked on it. But going on that, because you mentioned it, I want to talk about Nemo guardrails because I've now been to a few conferences where guardrails has been brought up. And it feels like something I could have used in that project because it was conversational based. And I specifically, Jonathan, I'd love to hear about like
Sure.
how does the DSL work, and then how does it interact with these external frameworks like like say vector databases like Redis or LangChain or any of the other LLM pieces that we've mentioned so far.
Yeah, so the concept of a guardrail is anything that monitors a communication between a human and an LLM, um, uh, validates that the conversation is, meets with some requirements, and then tries to steer it back if it goes off the rails. So like that's what a guardrail system should try to do. We released this toolkit called Nemo Guardrails, which is an open source toolkit. Um, at its heart, it's a dialogue monitor. A dialogue modeling system. Um, if you think about when you're talking to a language model, it's not like a programming language. You're not issuing commands. If you talk to Chat GPT, you're having a conversation with it. There's back and forth. And so there's like a whole field of dialogue modeling. When people talk to interactive systems, who said what did you intend, what were the can you extract meaning, What is the context of the conversation? In what context did this response make sense? And so that's actually the core part of the NEMO guardrail system, is this dialogue modeling system. Um, it's described, you describe these dialogues in a modeling language called Golang, which is a little bit confusing name. It's not Golang, it's Golang with a C. I think that maybe a small point of confusion. But Golang it's a very simple language, that the semantics are rigorously defined, but the syntax looks an awful lot like English. So you can say things like, if the user asks a factual question, then look up the answer in a vector database and have the LLM generate a response. And the logic, that's clear logic, but those predicates are written in things that look very much like English. And so it makes it very easy to use. It's very powerful and general. The way the guardrails actually work is, so you can have these checks. Did the user try to insert some kind of prompt injection? Did if the LLM stated something factual, let me double check it with a fact checking model. And the implementation of all of those guardrails, all of these rules, today it natively supports LangChain. So anything you can implement in LangChain, you can use in NEMO guardrails. We could support other applications, but LangChain was a good straightforward choice. And so because of that, through LangChain integration, you can access anything. Vector databases are obviously super powerful and convenient. Models, classifiers to detect hate speech, classifiers to detect intent. It has built into it, Guardrails has built into it this kind of intent modeling system because it's a dialogue modeling system. But really, any kind of analysis you want to do that you can call through LangChain can be integrated into NEMO Guardrails. So we think it's a very useful bit of functionality. The thing I'm hoping that it becomes is really a repository, because we open sourced it, of all of these best practices as people come up with new techniques for checking whether a response is factual or not, for checking whether this is likely to be a hallucination, for checking whether someone is abusing, or using abusive language, for checking whether someone is trying to trick the LLM into doing something that it's not intended to do. As people come up with these techniques, we thought, wouldn't it be nice if everyone put them in one place, and there was kind of an ecosystem built around this? I mean, we're certainly not going to solve the problem. No one group is going to solve this problem. But if we can create this kind of standard and this way to integrate all these things together, maybe this can emerge as a community solution. And so that was really our intention with NEMO Guardrails.
Yeah, that was really well explained, and that's definitely a project I need to dive more into, especially since I've heard so much about it recently. I feel like it's definitely gonna be very popular in the future. I want to, since I think we're coming up on our time here, I want to do one round where everybody answers the same kind of question. And so what I'll say is, I'm actually going to do two. So in the coming year, what do you think will be the biggest surprise, and then what are you most excited about in this AI space in the coming year? What do you think people will be surprised about, and then what are you most excited about? And if they're the same thing, then so be it. George, why don't you go first?
Well, I think one of the biggest surprises is how much the call it ability to really continue to scale up the number of tokens that are being thrown into these large parameter, large language models is going to certainly be challenged by how much more data we have left to be able to throw into them, and how effective we can be in terms of building call it the trillion plus parameter large language model. Whether we need it or not is quite uncertain. I think those trading runs will continue for sure, but I think we're even noticing now, at the end of the day, like GPT-4 is truly not a call it a single model, right? It's an ensemble of 8 models that are kind of strung together effectively based on subdomains that it's being trained on. So I think we're moving quickly towards a moment where we're going to have to figure out, more efficiencies in how the model training and the model inference plays out. And part of that, to me, does seem like we're going to run into more opportunities to build these sort of private domain specific models versus going after another big run of call it a 10 trillion parameter large language model. Maybe we'll see, but I honestly think we're going to run out of public human corpus before that happens. What I'm really excited by is the multimodality opportunities that are coming. Like I think we've started to work in single modalities, whether that be text or image or videos or acoustics, and we're going to be reaching a moment where there's multimodal. Now, whether that happens through just a transformer-based architecture, we'll see. But I think the combination of things like diffusion models that are part of the transformer architecture that's really focused on image videos, things that are kind of more highly tuned for audio, things that are continuing to evolve in the LLM world. Those are going to start to, I think, converge into multimodal opportunities in terms of just building these models, and you're starting to see that already, effectively in some of the models where you can now input text and of course generate an image, but you can actually now input an image and generate some pretty colorful descriptions around an image. So you're seeing the sort of edges of how this multimodality will emerge, but I think there's going to be a lot more that's going to be surprising and amazing in how these emergent behaviors, particularly around multisensory perception, emerges around these large language models and sort of broadly the transformer architecture.
Yeah, I know one of my favorite things to play with is the diffusion models, and especially some of the text to image and seeing what I can make it generate. I have bought a larger GPU just to fit a larger diffusion
Yep.
model on my computer. So I totally agree. And the multimodality is really something that I think is also going to be interesting. Jacky, why don't you go?
Yeah, sure. My biggest surprise is honestly how the increasing number of people that is actually becoming more and more familiar with GPT, and also prompting and also understanding the intricacies and the nuances of both. And essentially, what's happening is that there's effectively more and more citizen prompt engineers now in the world, where people just in the last week alone, I've spoken to teachers, to environmental scientists, to lawyers and policemen who are all, using GPT and using prompts on an everyday basis, and are getting more and more familiar with it and more, expert at it as well. So my biggest prediction, and honestly, like this is how I see the future as well, is that more and more people are going to want to go even a step further and start messing around with, how can I, even as a non-technical person, how can I actually add guardrails to some of the prompts that I'm doing? How can I add guardrails to some of the, GPT completion that I'm getting as well? So just things like that. I feel like there's going to be a rise where we just see more and more of this, and it becomes a staple in our everyday work. So yeah,
Awesome. Yeah, and then the thing you're most excited about, it may be same thing.
same thing.
Yeah, no, I hear that. I hear that. I mean, obviously, relevance is lowering that bar, and that user experience getting easier and easier. I think ChatGPT started a lot of people realizing that lowering the bar to the utilization of these generative models was a really, really interesting way to get your reach to be broadened as a tool and as a toolkit. And I know relevance was probably released even before ChatGPT. So I know you've been doing that a long time. I can totally understand being excited about that. Jonathan, biggest surprise in the coming year and what you're most excited about?
Well, I think George hit the nail on the head. I think multimodality is coming. There's so much energy and activity in the research world around image, audio, text, models that can take in input in all these different forms and provide output in all these different forms. And I think people are going to be surprised with the kinds of capabilities coming out really soon. I won't even mention. I mean, there's just a ton of really interesting research at very active space. Imagine models that you can um, give it an audio clip and say, "Hey, can you tell me what he's saying there?" And it tells you what the person is saying, right? Or can you redo this, but make him give him a southern accent, and the person, it's the same audio clip now, but with a southern accent. I think these kinds of capabilities, they're not quite there, but we're pretty close. I think in the next year we'll see all sorts of things like this. Um, while I am excited about that, I think what I'm most excited about is this transformation of what the core model of computation is. We think of computers that computers have been sort of the same thing for a really long time. Maybe with like mobile and distributed computing, the model changed a little bit. But I think LLMs are this completely new kind of computer that are much more. I definitely don't want to anthropomorphize the technology, but they're much more human-like in how they reason, and certainly in how you can communicate with them, and they communicate back to you. Um, Something like Auto GPT or the LangChain agents, or broadly speaking agents, are like a little step in that direction where you're starting to say, like, well, what if instead of just a thing that processes text, what if this becomes essentially the computer? This is the operating system, the thing that decides what to do, that's calling APIs, that's interacting with the world. um, I think there's a ton of work we have to do to actually make that useful and safe, and deployable and computationally efficient. But I think we're seeing the beginning of a new way of defining what a computer is and what a model of computation is, and what is a programming language in this new world. Jackie calls it the citizen prompt engineer, but I don't know what you call that other than a programmer. It's just the programming language is like nothing we've ever seen before, and it's miraculous, right? What this is going to enable. So
It's a
I'm
programming language
super,
in English. Yeah.
yeah, or whatever language.
Yeah,
Yeah, I think it's
exactly.
super exciting to see that this evolving. My 2-year-old daughter, maybe when she's 5, she's programming a computer because she's just talking to it. I think that's possible. So I'm excited to see where this takes us, and in terms of the economic impact, that the impact to uh, the startup ecosystem. I mean, we're going to see just incredible innovation and incredible new companies emerging, creating products that we never even dreamed of, I think.
Well, I love that answer. I will go last and least. And I will say, biggest surprise, I guess, is more of like a realization, I guess. I think people are going to be surprised by how much these are used as tools rather than necessarily replacing individuals. There's a lot of kind of, I don't want, ill will against the replacement of human involvement using AI, and I think it's really going to surprise a lot of people how much they're actually more so used as tools, like a Jasper, or creating a chain like in Relevance, or being able to actually use something like or Redis has an external knowledge base. Like each of these individual pieces are going to be more tool like. Where you might record a song as a country music artist and say, make it a little bit more twangy, or something like that. It will be
Yeah.
more, almost like a carpenter and a hammer rather than, we're getting rid of the carpenter. And I think the thing I'm most excited about is actually, well, okay, it's twofold. Some of the work that with Nvidia is really, really interesting, and it's going to lead to some incredible performance things that I think are going to be really exciting, but also mostly semantic caching. Because I think it's a really interesting way to almost cache the compute of, like what Jonathan was saying, this new type of computer, right? And so semantic caching is almost like a way of caching that compute, and doing it really broadly. And if you can do both, caching and vector similarity, you have the ability to do this in a really interesting way. And so I think it's an interesting paradigm we're dipping our feet into right now, but I think we'll probably jump in the deep end here pretty soon. So semantic caching is my most excited about. I'll wrap up by saying just thank you to all the panelists. I know that you're all people that have really busy schedules, but I know that the audience is going to love to hear these answers. So thank you so much for coming and speaking today.
Thank you.
Thank you for having us.
Thank you, Jackie, George, Jonathan, and Sam. I learned a lot about what's already here and what's coming. Thanks for all the insights.